Hey everyone, Morgan here. So we're finishing off the Ionic Solutions lecture for AP today, page number 14. This is some practice math based on titration problems. We're titrating ammonia, which is NH3 and has a Kb value equal to 1.6 times 10 to the negative fifth. Okay? Now, before the titration starts, this is just your classic weak base. NH3 plus H2O to give us NH4 plus and OH minus. Do an icebox here. This is starting off as, actually it's 0.2 molar. 0.2 molar, ignore that. 0 and 0. Minus X, 0.2 minus X, plus X, plus X, X and X. So my Kb is X squared over 0.2 minus X equals 1.6 times 10 to the negative fifth. Okay, I can approximate that. X equals 0.0017, and that is hydroxide ion. So my POH is the negative log of that, which is 2.75, and my pH would be 11.25. And yeah, my pH should start out high because it's a base. So now let's add some 0.1 molar HCl. And what the reaction is going to look like is NH3 plus the H3O plus from the HCl gives me NH4 plus and H2O. Okay. This is going to be a buffer. I recognize that. So I have 0.2 molar times 25 milliliters, which is 5.0 millimoles. The H3O plus, I have 2 milliliters times 0.1 molar, which is going to be 0.2 millimoles. 0, ignore. Minus 0.2, minus 0.2, plus 0.2, 4.8 millimoles. 0 and 0.2 millimoles. Okay, this is a buffer. So pH equals pKa minus the log of HA over A minus. Now, turns out that I can get the Kb, which is the negative log of this number, okay, which comes out to be 4.8, and yeah, 4.8. And then I subtract that from 14, and the pKa is 9.20. Minus the log. HA is a small amount. It's 0.2. The NH4 plus is the HA. And this is 4.8. And that equals 10.58. That would make sense. The pH should drop because I'm adding acid. Now let's do a few more buffer region questions here. 12.5. So in this case, I have 5.0 minus 1.25, which gives me 3.75 millimoles of the A minus and 1.25 millimoles of the HA. So the pH equals 9.20 minus the log, and I have 1.25 over 3.75, and this equals 9.68. That's making sense. It's coming down because I'm adding acid. 25.0 milliliters. Well, it turns out that's 2.5 millimoles of the HA, so 5.0 millimoles of HA minus 2.5. That's going to give me 2.5 and 2.5. That's the midpoint. And I recognize that the pH equals the pKa at the midpoint. So that's 9.20. Okay. Now let's get almost to the equivalence point. 5.0 minus 4.99. 49.9 times the 0.1 molar. That's 0.1 millimoles, okay, of the A minus. And that's going to mean we have 4.99. Actually, I'm sorry, it's 0.01 here. Bad math on my part, 0.01. 4.99 millimoles of HA. So the pH equals 9.20 minus the log of 4.99 over 0.01, and that equals 6.50. All right. Dropping a lot, and now we're going to have a big drop, okay, because at this point we are about to hit equivalence. Now at the equivalence point I'll have no A minus, I'll just have HA, which will react with water, which is going to give me H3O plus and A minus. Now how much? Well, I've got 5.0 millimoles of HA divided by a volume of, and in this case it's 75 milliliters. The 50 milliliters I've added plus the 25 milliliters I start with, and that ends up equaling 0.066 molar. So ICE 0.066, ignore 0 and 0, minus x plus x plus x, 0.066 minus x, x and x. Ka at this point is x squared over 0.066 minus x, which equals, and I found my Ka by taking Kw divided by 1.6 times 10 to the negative fifth, and I got 6.25 times 10 to the negative 10th. I solved that. X equals 6.42 times 10 to the negative 6th, and that is equal to the H plus. Took the negative log of that, and the pH is 5.19, which makes sense because the pH at equivalence should be acidic. All right. Now, what if I just added excess acid, 51 milliliters? Well, I can do the same thing, 5.10 millimoles minus 5.00 millimoles. This is the HA. This is this one's just H plus, apologize. And this is the A minus. So that means I have 0.10 millimoles of H plus divided by, it's going to be 76 milliliters. That equals 0.0013. Take the negative log of that, and the pH equals about 2.88. All right. Hope you did well with those. Ask any questions that you might have in class, and we'll see you again soon. Thanks for tuning in. This is Morgan signing off.